This is proof 19 on the Unit 1.2 study guide. All right, proof 19 in the study guide is an algebraic proof. So you might notice there's no diagram that goes with it, but we do have a given statement, and we're told what we are to prove, which is that x is equal to 7. So let's try this one together. Remember that the very first statement we always write is our given statement. So our statement is going to be 6x plus 3 equals 9 times the difference x minus 2. And our reasoning, and remember our reasoning is like, how do we know that this statement's true? Well, we know this statement is true because we were given this statement. We always start with at least one given statement. All right, in the algebraic proofs, you're just using algebra, and you don't need to show your work in the proof, but you are more than welcome to show your work somewhere else on your paper. I'm going to, for the sake of not making this too confusing, I'm not going to show my work in this proof. But the first thing we would do here, the first thing I would do as someone who's done algebra for a long time is I would distribute that 9. So what I would do is I would rewrite this statement, 6x plus 3 equals, and when I distribute that 9, I get 9x minus 18. Now we've got to use reasoning in kind of a formal way. So if I think, what did I do? I distributed that 9. What property is that? Or what's the name of that rule? Or what definition allows me to do it? And it's a property, and it's the distributive property. So I'm going to write distributive property. And I'm going to abbreviate property because I'm running out of room. Just check with your math teacher. If you're in my class, it's okay with me if you abbreviate property. All right, next, if I go back to my statement that I just wrote. So now, within this algebraic proof, all I really have to work with is statement number 2. So I think, what am I going to do next? And there's a couple things you might do. You might subtract 6x from both sides. You might subtract 9x. You might subtract 3. You might add 18. I'm going to go ahead and subtract 6x because I know if I do that, I'll have a positive coefficient of x. So when I take 6x away from both sides, I'm left with 3 on the left, 3x minus 18 on the right. And again, if it helps to show that work, do it somewhere on your paper, just not in the proof itself. Okay, so now if I think, what did I just do to both sides? Well, I just subtracted 6x from both sides. So what property is that? That is the subtraction property of equality. And if you are in my class, Miss Collins's class, it's okay with me if you say subtraction property, but I need to see more than the word subtraction, because the subtraction property is a specific thing. It's a noun. Subtraction is just an action. So I really want a formal name for that reasoning. Subtraction property of equality. I will accept subtraction property. All right, let's look at item number 4, or line number 4. So next, again, we think, what would we do to both sides here? Well, if you're following these steps, you would probably add 18 to both sides next. So when I add 18, 18 plus 3 on the left is going to give me 21. And then on the right, I now just have 3x. So again, I'm not showing my work, but you're welcome to show your work elsewhere, just not in the proof itself. All right, so if I think of what did I just do, well, I just added to both sides. When we add the same number on both sides, when we add the same thing to both sides, that's the addition property. Well, my stylus isn't working. Oh, I know why. Sorry. You can't see, but as I was saying that, I was trying to write the word addition and it wasn't showing up. Okay, so that's our addition property of equality. And again, check in with your math teacher. Don't assume because I'm abbreviating it that it's okay with them. All right, last thing. We have a one-step equation now. Hopefully, if you were doing this algebraically, you would divide both sides by 3. That will leave us with the statement 7 equals x. And we could say that 7 equals x now is going to be our division property because we divided both sides by 3 to get there. So the division property. Now, you might feel like you're done. And if you get 7 equals x, it looks like you're done. But if you go up here to the proof, and this is where you might want to check in with your math teacher to see how much of a stickler, if you will, they're going to be about this. The proof doesn't say prove 7 equals x. It says prove x equals 7. So if you want to be extra 100% sure here that you're going to get full credit and you want to look like the best mathematician in the world, there's really one last step you could take here, and that would be to write x equals 7. And we did learn a specific property that tells us 7 equals x and x equals 7, that those are the same, and that is going to be the symmetric property of equality. So symmetric property of equality. I'm okay if you write an equal sign there. So we have symmetric property of congruence and equality. And that's it.